All right, welcome and good morning or good day to you if you're in another part of the world where it's already past morning. My name is Tom Tansey. I'll be your host today for the webinar. We'll go through the SunSpec Modbus interface and the SunSpec SVP Dashboard tool, which is used for repairing interfaces and testing interfaces for DER devices. The theme of today's webinar is getting ready for smart distributed energy under the IEEE 1547 2018 standard. This is a very important development in distributed energy in that we now have a smart two-way communications to these systems and advanced functions that allow much higher degrees of penetration, which means installation of distributed energy into the distribution grid. We'll also be covering aspects of how this affects folks in other parts of the world as well, because the smart inverter movement perhaps is most codified, specified in IEEE 1547, but in fact is happening in many other parts of the world. So as for the format for today's presentation, we are operating with an open mic. This is a go-to-meeting session. And so what we'll ask you to do is that if you're not speaking, please do mute yourself. If you have something to say, though, we encourage you to speak up. If you want to ask a question and want to do so more discreetly, you can do so by putting a question in the chat box, and my colleague Dylan will field those, and we'll deal them with them in context or an appropriate time. The main point is we want this to be an interactive session, and so that you get your questions answered, so that as you leave the session, you know exactly what to do in order to get your system prepared and on board. You will be receiving the slides at the end of this presentation, so no worries about that. As part of the standard follow-up, I'll provide you with that information. And finally, in terms of a call to action, if what you see interests you, we definitely encourage you to reach out to membership@sunspec.org, and you'll hear me repeat that a couple of times. So the email address is membership@sunspec.org, and you'll be able to get any of your additional questions answered, and indeed schedule a one-on-one meeting so that you can go through a further in-depth demo and get all your current concerns addressed. All right. This SunSpec meeting, like all SunSpec meetings, is governed by our antitrust and intellectual property agreement. And so I'll read that for you now. All SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and intellectual property provisions in the SunSpec member agreement. The agreement can be found at the link shown on the screen. SunSpec strictly prohibits market participants and their employees who participate in these activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. Please contact me or one of my SunSpec colleagues if you have any questions on this point. Finally, this session is being recorded, and by staying on the line, you are agreeing to having your voice and presence recorded as part of this proceeding. So thanks again for participating. In today's agenda, which is pretty action-packed, but I promise we'll move through it quickly, we want to explain what SunSpec Modbus is in the smart energy context. Now, we realize that some participants here are interfacing with devices that are not energy management systems or solar inverters. And so we'll make sure to address those concerns as well about how to interface to other types of devices, but the main focus is going to be on smart energy and how SunSpec Modbus relates to the IEEE 1547 standard and to other grid codes in this context. Secondly, we'll discuss the IEEE 1547 National Interconnection Standard. This, as the name implies, this standard was passed in 2018 and became law upon its ratification. That mechanism is, in the U.S., is the U.S. Energy Act of 2005 that made actually IEEE 1547 a national standard. There was a previous version, of course, the 2003 version, and IEEE 1547 underwent a major upgrade in 2018, such that it could address smart inverter functions and so that it could add data communications. In fact, IEEE 1547 now requires that every DER have at least one standard communication interface, where your choices are SunSpec Modbus or the two IEEE standards you see there, 2030.5 and 1815. So one final point about the IEEE 1547 National Interconnection Standard. It is adopted in each of the 50 states and incorporated into the state-level interconnection regulations. So we'll talk about that too. Third, we'll talk about the importance of SunSpec Modbus certification. And so this is, the SunSpec Modbus, again, is a data communication protocol. It's quite robust. It works in conjunction with the other standard protocols to complete a utility network. And what we want to impart upon you is that getting this interface certified is important, specifically if you are manufacturing a power conversion device or a system, because it will save you time and money as you go through functional certification under the UL 1741 SB and IEEE 1547.1 functional testing regime. So in other words, once you get to that functional testing stage, you want to make sure that you're not tripping over communication issues that may crop up. Second benefit, of course, of SunSpec Modbus certification is that it guarantees full interoperability with these other data communication standards used by IEEE 1547, and most notably IEEE 2030.5. That is the default utility to system communication standard used in California, and quite commonly this data communication network terminates at a gateway device that converts 2030.5 to SunSpec Modbus. So certification will guarantee that you have the end-to-end communication that you need to make the system operate well and work well for you in a profitable way. So once we get through with the rationale for why you should be interested in these standards and how to go about dealing with them from a business context, we'll get down to the real world example of how to prepare your products for market. There's a series of steps you'll need to go through to make that happen. One of those steps is interacting with development and test software. And SunSpec provides software in that regard. The SunSpec SVP Dashboard, which we provide to all members as a member benefit, so it comes at no cost. And that's used for development and initial debugging. And then we have the SVP Dashboard Plus Pack. That we offer for an additional fee, and that provides automated testing for SunSpec certification and for this 1547.1 functional testing that we'll also be discussing. Okay, without further ado, so SunSpec Modbus, well, what is it? It's comprised of two parts. The first part is a set of information models, and these information models describe the functional behavior of various devices that would make up a distributed energy system. And principal amongst those are inverters or power conversion systems, as are referred to in the energy storage environment. Secondly, the batteries themselves that interact with these devices, and as well as the meters, the weather stations, the tracking systems, and actual PV modules in some cases are also supported using the SunSpec Modbus protocol. As I mentioned earlier, what's significant about SunSpec Modbus in the present context is that has been named as one of the standard interfaces for the IEEE 1547 2018 standard. As you can see on the right-hand side of the screen, there are 3 of these standard interfaces. SunSpec Modbus, the one on the furthest to the left, this is the system network protocol. In other words, the field bus that would be used to tie together the components in a distributed energy resource system, including all the components you see listed on the left side. The 2 in blue, the 2 protocols in blue, IEEE 2030.5 and IEEE 1815, these are typically used for utility to system communications. And let's talk about IEEE 1815 first. This protocol is also known as DNP3. It is used for utility substation automation. As such, you'll usually only see it with utility-owned assets, which is in fact a minority of the cases in the DER environment. The one right in the middle, IEEE 2030.5, is the communication interface for utility to system that is most often used for non-utility owned assets, thus comprising probably upwards of 98% of all assets that you see on the network. Once you consider that this includes things like residential PV and energy storage systems, and may even, certainly will include communication to electric vehicle charging systems, and ultimately we believe this will even connect with electric vehicles. So you can see that there's many more connections there. What all of these protocols share in common is a common information model. In other words, the information that's conveyed across these protocols is uniform from protocol to protocol. Each one has its place, and today we're going to be focusing in on the SunSpec Modbus Field Area Network Protocol. Okay, so what is actually in the information model? It's in particular, what's in this, the SunSpec Modbus information model for DER are functions that are defined in the IEEE 1547 standard. And so these descriptions come directly from that IEEE 1547 functional standard. And so what DER Modbus interface is, it marries the communication interface to these physical functions. And as I said earlier, what we have intended to do in building the system in this way is to ensure a very high signal to noise ratio as we necessarily traverse these different communication protocols that comprise the overall grid system. And so if you want more information about what is the details of each of these information models, this would be a good thing to ask membership at sunspec.org when you follow up with a call for them. Okay, so that's SunSpec Modbus, and I said it's part of 1547, but what's 1547 itself? It is the National Interconnection Standard specified by the Energy Act of 2005. Interestingly, given the way that our governing system works here, of course, that any national laws need to be referenced in local and state level laws, and IEEE 1547 is no exception, where in fact the interconnection regulations of all the different states will ultimately reference this standard. And we'll see a map of this in a screen coming up. 1547 defines smart inverter functions for grid support. That's a mouthful, and so what does it mean? Well, the motivation for IEEE 1547 was to ensure that more distributed energy could come onto the grid. The prior version of IEEE 1547 did not allow for that. It actually, in the face of too much distributed energy, the individual systems could in fact start to trip off. With IEEE 1547, it's built to support very large collections of these PV and energy storage systems so that we can make this transition to a distributed and renewable energy future. Most notably, in adding complexity to the standard, the 2018 version added data communication capabilities as a core requirement. And so why did it do this? About 3 reasons. First of all is to enhance functional performance. So despite the fact that we now have systems that are able to adapt to changing grid conditions, well, the tolerances for what those conditions might be change, for example, across the seasons. And so you need a way to manage the grid and the end devices to account for these seasonal variabilities. You may also have imbalances in the system. That can also be addressed by tuning the DER systems using data communications. Secondly, we have the issue of interoperability. These DER systems are now grid supportive, and so if one is removed or replaced, we want another system to be able to stand in its place without the need for further re-engineering of the network. And so 1547 provides interoperability for that purpose. And then finally, remote management. Things will occur, things will need maintenance, and so when you have a standard communication network, you can do many of these activities to maintain systems from a home office. So remote management, another key component of IEEE 1547, and the data communication that comes with it. I mentioned the state level implications, and this drawing here is now about 6 months old, and it comes to us compliments of the Electric Power Research Institute, where they've been keeping track of state level adoption. And what you'll see is sort of a theme around the January of 2022 as being really a key rallying point. That was as of about 6 months ago. As we've dug into the details, some of the states have kept with that guideline in terms of the timing, and others are in the process of perhaps adjusting their dates. My crystal ball says that we're likely to see about a 6-month push out from these dates. So maybe 1 year from now, June 2022, is when you'll see IEEE 1547 2018 becoming acquired in the majority of the solar and distributed energy supporting states. And that's, I think, an important factor because it leaves about 12 months for manufacturers to get their act together, to develop and to test and get their products into the market. So this is definitely going to be a push. There's no question about that. There will definitely be competition that you'll see at testing labs, and development teams will be hard pressed to meet these dates. But we have faith that we'll be able to come through. I think people have been fairly engaged heretofore over the last several years, and now we're just really into the home stretch of pushing these IEEE 1547 systems over the line and into the marketplace. All right, so that's the good news, is that we're going to have IEEE 1547 systems, and we really like the fact that data communication is now part of all these systems. That makes them more capable. It also, 1547, links the communication interfaces to electrical functions. So you have the ability to make these remote settings changes and do scheduling and things of that nature. All of this taken together allows the 1547 devices to deliver on the promise of smart and distributed energy that can be managed from afar. IEEE 1547 has some drawbacks, though. And principal amongst those is that the testing procedure, the so-called IEEE 1547.1 testing procedure, covers only a small fraction of the capabilities of the communication interface. It ties together very specific settings for very specific functions and leaves the rest of the communication face unevaluated. And what this means is that if you were to rely on IEEE 1547 alone, end-to-end network interoperability it's not considered, and so it would be difficult to achieve. And that results in the fact that there's no guarantee through IEEE 1547 that the data communication interface is fully operable. So we're mentioning this because the DER networks need to work correctly in order for the entire system to work correctly, and they are unlikely to do so if you rely only on IEEE 1547.1 for compliance testing. What we recommend instead is that you get your interfaces certified. SunSpec is set up to provide this certification service. We've been doing so for about a decade now, although I have to admit that within about the last year to 18 months, the demand for certification has gone up dramatically as it coincides with the rollout of smart distributed energy. With the SunSpec certified service, we are able to do a complete evaluation of all of the required protocols, including SunSpec Modbus and IEEE 2030.5. And with that, we confer a mark that we have done this type of certification. We put that information on a website that you'll see in a moment. And this is the guarantee that the product is compliant with the relevant standards. Now, SunSpec Modbus standards in particular have a very broad adoption amongst the DER equipment manufacturers. About 30 to 40 of these manufacturers have gone for SunSpec certification so far, with more on the way. In a survey done by the California utility, Pacific Gas and Electric, they determined that about 70% of their installed base will support the SunSpec Modbus interface following the adoption of IEEE 1547. And so why is that? Well, again, the Modbus interface is the one that's designed for field area networking. It's also included, Modbus is included in most of these core machines. So adding the SunSpec information models is in fact the easiest thing to do to gain this type of compliance. So with that, we do offer certification profiles that are bound to very specific use cases. Now, some of these profiles we are offering now, and then some are in development and others still are on the roadmap. As of today, we provide an IEEE 1547 compliance profile for solar DER systems. We are intending to and are working on an energy management profile, and we've seen recent demand for rotating machines. So one thing about IEEE 1547 is that it covers any machinery that would connect to a utility grid, and that could be a mechanical system, a rotating machine to generate power. So that's another use case that we will support. In addition, in development, we have a Society for Automotive Engineering standard for medium duty and heavy duty electric vehicle charging. This standard will use most of the IEEE 1547 interface. It may, if not all. It's been in development for a couple months now, and we're expecting that that standard will be available later this year. In addition, Poland has supported SunSpec Modbus, so we offer certification for that jurisdiction. Australia is in the process of coming on board to support the interface, as are countries like Austria and Germany. I know that Brazil seems to be also considering adoption of this particular interface. The reason why, these products are manufactured by global manufacturers and they're shipped to all markets. And so to the extent that we can get economies of scale by providing this distributed energy resource technology deployed in a uniform way across the globe, we can make these distributed energy systems more affordable and therefore more useful to all these different economies. I mentioned that an offshoot of certifying the product is being listed on the SunSpec website, and that certification registry comes with all the details that an authority having jurisdiction would need to make a decision as to whether your product is applicable for a given grid code. So as you can see here, this is just takes it's the SunSpec Modbus interface. This is about as of, I want to say maybe 1 or 2 months ago, and there's been other products that have been certified since this time. But with the information provided on this website, you can quickly determine what makes and models of products have been covered and what SunSpec information models are used. You can also get details on their protocol information conformance statement. And this is ultimately the thing that a state level authority having jurisdiction would check to see, is your product valuable or eligible for installation in a given jurisdiction. All right, so what we recommend to vendors that are going about getting certification for 1547 is that you start with SunSpec Modbus and certifying that interface. You can get this done by working with any of the SunSpec accredited labs, and you see at least some of them there. That we've added more since that time. And in fact, if you go about getting your interface certified first, what that does is ensures that once you get into the process of validating the functionality of the electrical functionality under the UL 1741 SB standard and the IEEE 1547.1 test standard, that you're only dealing with functional errors. We'll see in a moment why that's so important. Some of these IEEE 1547 tests may take as long, a single test may take as long as a full day to execute. So if your interface is certified, this means that you can potentially save days or maybe even weeks of lab testing time because you are assured that the communication interface works and that the failures or the defects that you're dealing with are really those that are limited to the physical or functional aspects of the product. So this is, I think, is the most compelling argument for getting that communication interface. And I would say the same thing if it's an IEEE 2030.5 interface or an IEEE 1815 interface. If you get that interface evaluated first, that means that you don't have to worry about it and focus strictly on the functional testing. Second benefit of getting SunSpec modification certification in the first place is that you are then guaranteed to interoperate with IEEE 2030.5 utility networks. So this sounds like a funny statement. If you certify to one protocol, that guarantees interoperability with another protocol. But there's actually a logic to it, and that is that these two protocols carry exactly the same information across the two of them, and they've been designed to work together. They are built for different purposes. As I mentioned, the Modbus is a field area network protocol versus 2030.5, which is for the wide area. So what this means is that within the real world where these systems are built and deployed at scale, you're going to see a lot of these gateway devices. And so by getting certification, you can reduce your cost of integrating products in the field, and instead of doing your debugging, you're doing more selling and less technical support. This chart illustrates a very common configuration that you'll see in DER systems, where on the left side, you'll see the PV or the energy storage system that will typically present a SunSpec Modbus interface. It will then communicate with the gateway device, which is effectively an embedded computer with an operating system, where a translation occurs to the IEEE 2030.5 protocol or the 1815 protocol, for that matter, for upstream communications to either aggregation services or directly to the utility servers. So this is in effect a standard feature, and again, the reason why we recommend SunSpec Modbus certification for this purpose. All right, so that's the rationale for what you should do. Now let's get into the question of how do you do it. Most of you, I think, that are involved in developing DER products have already found your way to the IEEE website where you've downloaded the IEEE 1547 2018 standard. If you haven't, you can find it at the link shown. Next up, looking down the page immediately below the 1547 standard on the left-hand side, you will find information about the SunSpec Modbus interface. And there we recommend that you focus in on 3 documents: the DER information model specification, the device information model specification, and the spreadsheet, which is used to develop your picks. All 3 of those documents are available at the link shown on the SunSpec website. As you start up with your development, you may want to do some learning about how one of these interfaces works once it's fully constructed. So we offer the SunSpec SVP Dashboard to all SunSpec members included in their membership. This SVP Dashboard includes a fully functional DER simulator. So this allows the Modbus master in SVP Dashboard to connect with the client in the DER simulator. And there, you through validation, you can see, again, through sort of trial and error, about what works and what doesn't work. So those are all good places to get started. Looking down on the right-hand side of the screen again, we offer open source software in the form of PySunSpec 2 with the IEEE 1547 update. We've also updated our support library, so it's now PySunSpec 2, and it's a Python language library for interfacing with SunSpec devices. Again, tried and true. As your product nears completion and you're now starting to test it, we offer SunSpec SVP Dashboard Plus Pack for that purpose. All those things will help you to get to market quicker. All right. Now we're going to switch our attention and talk about the SunSpec SVP Dashboard. It's been introduced to you at this point. Now, before I move on, though, I do want to address some of the questions in the chat. And Ujjwal Shah asked, is it possible to add a module? And I think I'm going to interpret this to say, is it possible to add an information model and into the SunSpec Modbus scheme? And the answer is yes. We have a facility for vendor-defined models that have capability that only your device has. Now, the benefit of SunSpec Modbus vendor-defined models is that they can be accessed and discovered in a standard way, such that your special features can be exposed. And he asked again, if some parameters require needing to be added, is it possible? Well, what I would say, Mr. Shah, is first of all, as it pertains to the IEEE 1547 standard, the parameters involved in the 700 series models are intended to be comprehensive. Those have been debugged over several years now, and those, in fact, are everything that you'd need for a 1547 compliance. Now, we also offer, of course, information models for batteries and meters and all the like. So we would recommend that you first take a look at our information model library before making the determination if you need something new. Taesik Kim asks about, how about the security perspective? That is a very good question. As we have rolled out these standards, the conversation has quickly shifted from interoperability to security. And I have this to say about security. Actually, we'll go back 2 pictures here. Okay, so let's talk about security first of all from an overall system perspective. So in this network topology, you have on the far right-hand side, you have utilities and you have aggregation services. These are both managed environments that may have physical security around them that would protect the computers. Now, as the data traverses outside of the aggregator or utility facility, it is encrypted, and mutual authentication takes place between the client and the server. So in other words, the server says, hey, do I know you? And the client also says, hey, do I know you as a server? So their mutual authentication occurs and strong data encryption occurs at that point. Over on the SunSpec side, on the Modbus side, Modbus up until 2019 had no provision for over-the-wire security. Now you can utilize SunSpec Modbus with transport level security to talk on within the grid system. Now in very small systems, these Modbus connections may in fact be buried inside of sheet metal, or they may be very short, or in fact the system may be installed in a house or a building. So you have physical security wrapped around them. So for this reason, and also for the reason of effectively the low risk of compromise of a single component in a DER system, a lot of system designers have chosen not to encrypt the data on the DER system side. However, if you want to, and if you have the need to, you can absolutely do that. Now, another aspect of security is, well, what about these gateways here? And the gateway specification is not subject at this point to certification, although it soon, I believe, will be, where we'll be looking at hardening the operating systems and actually hardening the physical cases around these embedded computers. So we definitely have a plan for that. But right now, the security within these systems is primarily focused in on over-the-wire type of security. All right, let's see here. Robert Mendoza asks, SunSpec Modbus still doesn't get information on the panels and or other sorts of measurements. Actually, Robert, we have both command and control interfaces to things like trackers and meters, combiners, and the like. So in fact, we are able to diagnose and get telemetry data from every part of the system. Okay. David Heron, yeah, I think Modbus, as you say, inherently has no security, but there is a official TLS standard for that. Sam Yasser asked, how are utilities companies implementing their end of the DERMS? For example, I'm working with a local utility company that is requiring the capability to be able to disconnect and connect DERs and to limit maximum active power for DERs. How will then will be able to issue these commands from their end to reach the DERs, DER gateway, and control DERs at my project? Okay, great question, Sam. That is the subject of this IEEE 2030.5 protocol, and in fact, the whole system you see here is to enable that remote sort of command and control. Now, quite often, command and control will be intermediated by an aggregator. So where a utility will ask an aggregation service to set parameters on these DER systems, and so then it'll propagate those settings changes downstream. Or usually with larger systems, the utility itself can make the same command and control case using these protocols. But yeah, that is really the purpose of these IEEE 1547 protocols, is to enable those use cases that you described that your utility wants to do. And those functions that you mentioned are all included in the standard. Okay, and with that, let's go on to the next step and get into the SunSpec SVP Dashboard. We'll have more chance to answer more questions as we get towards the end here. All right, so the SunSpec SVP Dashboard family has two members currently. The dashboard itself, it is used primarily for product development, so by software developers. It's sometimes used by field personnel for doing diagnostics as well. It's available to all SunSpec members at no additional cost. So when you become a SunSpec member at $3,000 per year, this is one of the benefits you get, is this type of software. We offer also the SunSpec SVP Dashboard Plus Pack. This system is an add-on, as is indicated by the Plus Pack. It's an add-on to SVP Dashboard, so no additional software to reinstall, it's just simply adding in new features and activating new features. It's used for SunSpec certification and for IEEE 1547 functional testing. We do charge an extra fee for this, and if you're interested in learning more, please do schedule an appointment with us. We'll be happy to go through the options with you. So that's what's in the family. And how does it work? It installs in Windows 10 as a normal application. It is a hybrid type of a product, though. It runs as a local web service where it's interacting with the browser. And so this is a fairly unique type of architecture. What it gives you, though, is the ability to command your device using a graphical interface through one of the browsers supported there, Chrome, Firefox, or Edge. But in addition to that, it provides a RESTful web service interface such that if you have a test environment that does other types of functional testing, for example, you can integrate this communication testing capability through an API. All right, and with that, let's see a demo. All right, as the system starts, you'll be in the Windows 10 environment. As we mentioned, we do support other versions of Windows, but this is the default one, I think, for industry these days. And so here goes the demo.
Once the dashboard is started, you'll see this opening screen. This screen represents the web service that's running. If you close this screen, the dashboard will close. To access the user interface, you can click on the link in the window, and a tab in your browser should open automatically, and the dashboard screen will be minimized on the toolbar below. This organization allows the dashboard to be integrated into other tools environments and be accessed through its web service API to perform operations. This is especially useful for interfacing with the testing functionality contained in the dashboard from other testing environments. Once open in a browser tab, we see the dashboard display with the menu items above. In the top level menu items are Device, Tests, Tools, and Help. One of the primary sets of functionality in the dashboard is the ability to interface with a SunSpec compliant device through the SunSpec interface. The items in the device menu support operations associated with the device. The device menu contains Open, Close, Create PIX template, Create certification test, and Export. To perform any of these functions associated with the device must first be opened. We'll open a device in a moment. The Create PIX template and Create certification test menu items are used in the device testing process. We'll look at those in a minute. The last item in the menu is Export. Export provides a way to save the data contents of the device to a file for later use. The Test menu provides access to test suites that have been created in the dashboard. We will see how test creation works when we look at testing. Tools menu contains additional functions that are useful in the SunSpec environment. The first two items, Models Directories and Update Model Definitions, are used when working with model definitions. The last item is DER Simulator, which provides the ability to create SunSpec compliant DER simulators for development and testing purposes. And the last menu item is Help. In the Help menu are User Guide and About. The SVP Dashboard User Guide opens in another tab and contains information about all the available functions and provides tutorials explaining function usage. The User Guide can be referred to at any time for help and left open in the tab. The second item in the Help menu is About, which gives information about the dashboard, including version, dashboard ID, which is important when getting the dashboard license, and the information about licensing. Now we'll use the dashboard to create a simulated DER and open it as a device. I'm going to start a simulator, which defaults to a standard IEEE 1547-2018 compliant implementation using the SunSpec DER information models. The simulator defaults to Modbus TCP on port 8502. The dashboard supports Modbus TCP, Modbus RTU, and an additional device called File. The Modbus TCP and RTU options provide the standard networking options for each. The third option allows previously exported devices to be loaded and used as device data. This allows simulated interaction with a device image for testing and debugging purposes. Using the Device Open option, we can interface with the simulator. We see the display window populated with two kinds of model information. In the top bar, we see the information model IDs of the models that were discovered in the device. And in the main portion of the window, we see the detailed information for Model 1, the selected model in the list. Each row in the table represents a data point in the model. There are three main columns of detailed model information for each point. The left column is the data point label and point name as defined in the information model definition. The middle column is the current value for the data point, and the right column is the Modbus address of the data point and the data contents as it would be seen in a Modbus message. Looking at a more complicated model, such as Model 705, which is DER volt var control, we can see all the points associated with the volt var model. Points that are writable have input fields that allow them to be updated here and written to the device on command. We can see this volt var model implements three control curves. Using this interface, we can examine and update all the points in a model. The dashboard can support all models that have a model definition, including vendor-specific models created by manufacturers. Now that we have an open device, let's look at the testing-related options. The two options associated with testing are Create PIX Template and Create Certification Test. When testing and certifying a SunSpec Modbus interface, a Product Implementation Conformance Statement, or PIX, must be submitted. The PIX is a detailed implementation statement in the form of an Excel spreadsheet that indicates which models and points are supported in the implementation. The dashboard uses the contents of the device to create an initial PIX template. The PIX template is then updated by the submitter to add any information that could not be determined by the dashboard. Once the PIX template is complete, the dashboard can dynamically create a certification test suite based on the PIX template. The certification test suite contains tests for each of the models contained in the device. The testing ranges in the tests are based on the supported ranges specified in the PIX for the points in the applicable models. When a test is created, it is added to the test menu. This menu contains a test that was created based on the PIX associated with the current simulation configuration. We can access the test environment by selecting the test in the test menu. The test environment opens in a new tab. On the left, we can see the complete test suite associated with the device based on its PIX. Within the top-level suite, we see test suites based on each of the models contained in the device. Each model test suite contains a set of tests that are applicable to the model. Looking at the volt var test suite, we see the individual tests that are run. We can select any combination of suites or tests to run. I'll select the volt var test suite and run it. As the test runs, a result indication is given for completed tests, and a progress indicator shows which test is currently running. You're also able to stop the test run at any time. I'm going to stop the test now. The test results and the detailed logs for each test in the test suite are saved in a results file. The results files can be inspected later using the same interface with the same navigation capabilities that are available during testing. Here we see a full test run completed earlier and are able to browse the detailed test results. As mentioned earlier, the test can be selected and run through the graphical user interface or through the web service API, allowing the test selection, initiation, and results retrieval to be integrated into another test system. This has been a quick overview of the full functionality of the SunSpec SVP Dashboard. Some of the functionality shown may require additional licensing beyond the SunSpec membership license. To get more information about any of the features, check for additional demonstrations and documentation on the SunSpec website.
All right. Great. Well, one of the points I would like to make about what you just saw there is that the demonstration was with a DER device. And so when it was probed for models, what came back were the 700 series. Now, if you have a meter device, what would come back is the 200 series of models, or a tracker, the appropriate series there, or the batteries for 800. So again, the point is that all SunSpec models for all types of SunSpec devices are supported in this this same regime. Now I want to get back to answering a couple of these questions that came up on the chat. Pablo was asking on the slide that showed the gateway, is the SunSpec Modbus the Modbus server, or rather the client and the DER the master? Well, the Modbus server in that particular case runs on the DER device, and the client actually is in the gateway. So yeah, thanks for that clarification. And let's see here. Next up, yes, let's see here. Okay, I think that pretty much does it in terms of the questions that came up on the chat box. Would anybody else like to ask a question? Okay. All right. Well, if there are no questions at this time, I would just like to say that if you are interested to learn more, contact the email link that you see there below, and we'll be happy to answer any questions you have. We'll go through a private demo. If there's a particular use case you'd like to go through, we can make that happen as well. There are lots of other benefits to SunSpec membership, as you'll see. And so our point is to make the experiences as rich and fulfilling for our members as we can as we build out this distributed energy future. I'll also add that some people have asked us, well, what about instruction about the intricacies of working with SunSpec Modbus protocol? We've in fact created a 3-unit course that's available for registration now, both at UC San Diego and I believe also at North Carolina State University as well. They're offering the same course this summer. This confers full academic credit, but you don't need to do that. If you want to take it for non-credit, you can do that. Also confers NABCEP credits along with it, and goes into great detail about how to utilize this system. It's taught by Bob Fox. And if you're a SunSpec member or you're a veteran, please do contact membership at sunspec.org, because there's a discount for you on this course as well. All right, let's see if we have any final questions or thoughts here. Oh, Thomas Simo says registration on the course actually ends June 22nd, so you have a little bit of time there. Okay, any other final thoughts before we wrap today? If not, I really do want to thank you for your time and your attention. We hope that you will consider working with us. And if you, again, like to learn more, just contact membership at sunspec.org. And we have captured all the additional questions in the chat box, and we will make sure to address any questions that we haven't already done so when we follow up with you to send the presentation from today's webinar. Thanks again, and have a wonderful rest of your day. Bye for now.